So guys, going forward, now let us discuss one end-to-end example here. In this example, we will going to combine the functioning of L2 switch as well as ARP protocol together so that we understand that how the two concepts work together in order to make L2 routing possible. So in this example, you can see the topology in which I have two L2 switches, right? And in this topology, I have 6 host machines. That is host machine A, B, C, and D, E, F. We will take an example in which the host machine C wants to communicate with host machine D, right? And this entire subnet is supported by two L2 switches. You can see that the IP addresses are configured on all the host machines such that all the host machines are present in the same subnet whose network ID is 12.1.1.0/24. So all the host machines derive the same network ID. In this topology, we will be using two types of table. That is ARP table. So the end host machines will have ARP table. You can see these 3 empty boxes drawn against each host machine in this diagram. This empty box actually represents an empty ARP table. And since we have two L2 switches in this topology, therefore we have two MAC address table which are currently empty, and these two MAC address tables corresponds to two L2 switches in this topology. So to start with, we have assumed that all the ARP tables and all the MAC tables in this topology are empty. So going forward, so in our problem statement, we have host machine C, and this host machine C wants to communicate with host machine D. And this entire subnet is supported by two L2 switches. So now let us discuss the steps which makes the communication between the source host machine C and destination host machine D possible. So step 1. C wants to send a data packet to destination host machine D whose IP address is 12.1.1.2. Now this IP address is a user input. Now the next thing that C does is that it verifies whether the destination IP address which it tries to communicate with is in its own local subnet or is present in a remote subnet. So in this case, the destination IP address 12.1.1.2 belongs to the local subnet of host machine C. Now when we will be discussing the L3 routing, we will cover the scenario when the host machine detects that the destination IP address with which it is trying to communicate with belongs to the remote subnet. But for now, let us confine our discussion to a scenario where a destination machine belongs to the same subnet as source host machine. So in step 3, the host machine C validates that the destination machine belongs to its own local subnet. When this happens, then source machine C look up its ARP table with destination IP address 12.1.1.2 as key. Now we have assumed that ARP table of all the host machine in this topology is empty. Therefore, the source host machine C will not find the IP address to MAC address entry in its ARP table for destination machine D, right? So as a result, host machine C launches ARP broadcast request. So the content of ARP broadcast request will be that source MAC address will be the MAC address of machine C, destination MAC address will be the broadcast address, and it is resolving an ARP for IP address 12.1.1.2. So at this point of time, the source machine C has launched ARP broadcast request out of all the interfaces which belongs to the subnet 12.1.1.0/24. In this example, the source host machine C has interface IFC which is operating in this subnet. Therefore, it will launch ARP broadcast request on the interface IFC. So going forward, now L2 switch 1. Now let us suppose that this is L2 switch 1. This L2 switch 1 receives ARP broadcast request message, and therefore the L2 switch makes an entry in the MAC table. So L2 switch 1 will learn that the host machine whose MAC address is MC is sitting behind the port P8. In the next step, L2 switch also inspects the destination MAC address present in the Ethernet header of this ARP broadcast request message. But since the destination MAC address in this ARP broadcast request message is a broadcast address, therefore L2 switch simply floods this ARP request message out of all the ports, that is port P5, port P6 and port P7. Now you can see that in step 7, the host machine A and host machine B also receives this ARP broadcast request message, but they simply discard this message silently. Why they discard the message silently? Because their IP address do not match with the IP address for which this ARP resolution is being happening. You can see that ARP resolution is being done for 12.1.1.2. Therefore, any machine whose IP address do not matches with the IP address for which ARP resolution is being happening, then that machine will simply discards the ARP broadcast request message. So in this case, the host machine A and B simply discards this ARP broadcast request message. Now in the next step, this ARP broadcast request message is received by L2 switch 2. So when L2 switch 2 receives this ARP broadcast request message, it will also update its MAC table, right? And like L2 switch 1, it also floods this ARP broadcast request message out of all local ports. Now host machine E and F receives this ARP broadcast request message, but they simply discards this ARP broadcast request message for the same reason which I had explained in case of host machine A and host machine B. So as a result, in step number 10, this ARP broadcast request message is received by the host machine D. Now the host machine D will reply with the ARP reply message. Why it chooses to reply with the ARP reply message? Because it receives the ARP broadcast request message and the IP address for which ARP resolution was taking place is same as the IP address of the machine D. Therefore, the host machine D will reply with the ARP reply. Now the content of the ARP reply message will be the following. That is, destination MAC address will be the MAC address of machine C. The source MAC address will be the MAC address of machine D, and the contents of the ARP reply simply says that MAC address for IP address 12.1.1.2 is MD, right? So the host machine D sends back the ARP reply message. Now this ARP reply message is received by L2 switch 2. So remember, whenever L2 switch receives any packet, the first thing it does is to update its MAC address table by inspecting the MAC header that is contained in the packet. So this L2 switch will inspect the source MAC address in the ARP reply message and it will make an entry in its MAC table. Now in step number 12, L2 switch 2 also reads the destination MAC address in the packet, which is actually MC. So L2 switch 2 forwards the packet to port P1 because it already has an entry in its MAC table. So you can see that L2 switch 2 already has an entry in its MAC table, and using this entry, L2 switch 2 will forward the frame out of port number P1. So similarly, L2 switch 1 receives this ARP reply packet and it does the MAC learning. So it will install an entry in its MAC table. And L2 switch 1 also inspects the destination MAC address in the Ethernet header of the frame to forwards the packet. So L2 switch 1 ends up in forwarding the packet out of the port number P8. And finally, the host machine C receives the ARP reply. So when the host machine C receives the ARP reply, it will update its ARP cache. So in the ARP cache, the host machine C has made an entry that for IP address 12.1.1.2, the MAC address is MD and outgoing local interface is IFC. Now let us see that once the host machine C has an ARP resolution for IP address 12.1.1.2 with which it is trying to communicate with, then what is the packet content that is generated by host machine C? So going forward, now we have assumed that all the host machines in the topology have populated its ARP table by issuing the ARP broadcast request messages. And we have also assumed that the L2 switch 1 and L2 switch 2 have populated the required entries in their MAC table, which is required to make the communication between the host machine C and D possible. Now, when host machine C has its ARP resolution done for destination IP address 12.1.1.2, this is the frame that will be prepared by the host machine C. Please note that I have specified only the required fields which are required in order to make the communication between the host machine possible. All other unnecessary fields I have omitted. So you can see that this is Ethernet header, and in this Ethernet header or MAC header, the destination MAC address is MD, which the host machine C has obtained via ARP resolution. And the source MAC address will be the MAC address of the source machine C. That is the MAC address of this interface. In the IP header of the packet, that is in the second layer of this diagram, the source IP address and destination IP address, as you can see, will be the IP address of the host machine C and D respectively. And then you have the transport header, or it could be application header, and you will have a required payload on the top of IP header of the packet. So you can see that when the source machine C issues this packet and places this frame on the wire, you can see that L2 switch 1 will inspect the destination MAC address in the frame, and it will know that it has to forward the packet out of interface P6. So the packet will be forwarded out of interface P6. Similarly, L2 switch 2 will receive this frame, and it will again inspect the destination MAC address specified in the Ethernet header of the frame, and it will use this entry to forward the packet out of local port number P3. So you can see that simply the packet is forwarded from host machine C to host machine D by L2 switch 1 and L2 switch 2. And no other machine in this subnet ever sees any such frame which is generated by the source machine C and destined to the destination machine D. So you can see that using L2 switches, the problem of thrashing is completely resolved. There is absolutely no thrashing at all. So this was the concept of L2 switch and ARP protocol for you. So with this, we have completed the basics of L2 routing. We will come back again on the topic of L2 routing when we will be discussing the concept of virtual local area networks, that is VLANs.